Hello, Room 10. This is one of the last movies of the year as we finish off our last chapter 28 with surface area and volume and 3D solids. A 3D solid, or a 3D shape as many people call them, is anything that has both length, width, and height. Width is sometimes also known as depth. There are two different things you can do with 3D solids: find the surface area or find the volume. And the class and I have worked on listing out some of the tails of the tape, if you want to think of this as a boxing match. In the red corner with surface area, we have a focus on the outside of a three-dimensional solid, whereas on volume, we're dealing with the inside of a three-dimensional solid. We solve for surface area by adding all the areas of each face using the formula area equals length times width. In our shape down below, which we'll be solving in just a moment, there are 6 faces. There's a top, a bottom, there's a front and a back, and a left and a right. For volume, we deal with all 3 dimensions, length, width, and height, and we simply multiply them to figure out the volume of our solid. Our answer for surface area, since we're dealing with a 2-dimensional side, or face, we deal with square units, since we'll be taking inches and multiplying by inches. It gets us inches squared in this particular problem, or unit squared. For volume, since we're using 3 dimensions, we'll be multiplying the units in all 3 of these dimensions by themselves to get units cubed, or cubed units. I'm going to do 2 demonstrations here to show you how to solve both surface area and volume for these problems. Something we've worked on in class that the kids have found helpful is to think of this as a box, and this box has a top and a bottom that are exactly the same size. It has a front and a back, which are also the same size. The box has the same qualities as a rectangle. The opposite sides of the rectangle are equal to each other. Opposite faces are also equal to each other. There is also a right and a left face. So we sort of separate this into 3 different categories, since they will all have the same measurements. For the top and the bottom, the easiest thing to see in your 3-dimensional drawing here is the bottom. And you can see it has a length of 7 and a width or depth of 3. So by following this formula here, we're just going to be multiplying length times width, and the bottom and the top are both going to be the same, for 21 inches squared. Since these are both inches, we're multiplying inches by inches, which is squared. The front is this face right here. It's also the same as the one in the back. We're dealing with length, 7, and height, 4 in this instance. They're identical, so we have 2 measurements, both of 28 inches squared. Last but not least, we have a right face and a left face that are equal to each other. We're dealing with width, 3, times height, which is 4, for a total of 12 inches squared. That's repeated for the left. Now, to figure out our surface area, we simply add all these up. 8 and 2 is 10, 8 and 2 is 10 again, that's 20, plus the 2 up top is 22. 2, 4, 6, 8, 10, 11, 12, for 122 inches squared. Now, what you're imagining here to help you understand the squared is that if each one of these faces has a length and a width, we're imagining how many squares might fit across its face. Keeps it in 2 dimensions and helps us understand the term squared. Now, volume, on the other hand, uses all 3 dimensions, length, width, and height. And you simply have to multiply the 3 of them together. 7 times 3 times 4. Anytime you're multiplying 3 numbers, you have to make a decision to multiply 2 of them first. We use parentheses to show 7 times 3 is done first. And when we multiply that by 4, we get 84. Since we are multiplying inches times inches times inches, that's inches cubed. One thing that'll help you understand some real life examples. Surface area would be if you wanted to paint this box or wrap it in wrapping paper or cover it somehow. This will let you know about how many square inches of material or paint you would need to cover it. Volume over here, this would be if you wanted to fill this box up, assuming that the top was open, with dirt or with cubes, if you want to think of that. We took a three-dimensional solid that we made in class here, and we filled it up with cubes. We found that we had 3 layers of all these cubes here, and that was a nice way for us to understand what cubic units mean. You're actually trying to figure out how many cubes you could fit inside there that are of a certain dimension, squared inches in this case. So I hope this helps understand surface area and volume. Thank you much.